This is our second part of exercise 10.02. We've looked at one type of problem, which is like a projectile, a ball being thrown, a plane going down and then up, all right? They're your typical types of problems. Generally, a ball being thrown is the most typical type of problem. The other type of problem is one of these area problems, where you've either got 4 sides of the fence, and in the next example, you'll see 3 sides of the fence, all right? Because when we work out the area, it'll be one dimension times the other, and we're going to end up with a quadratic equation when we put unknowns like x's in these. So here, in this example here, Farmer Brad has 18 metres of fencing and wants to build a rectangular pig pen with the largest area possible. Now, because he's got 18 metres of fencing, that's the perimeter. So looking here, he could go 7 and 2, that's 9. And another 7 and 2, that's another 9. See, that's 18 metres perimeter. But the area is 7 times 2, which is 14. Or he could go 5 plus 4 is 9, and another 5 plus 4 is also 9, but the area of this is 20. Can you see it's bigger? Or he could do, doesn't have to have whole numbers, he could do decimals. 5.5 and 3.5 is 9. 5.5 and 3.5 is also 9, so the perimeter here is 18, but the area is 5.5 times 3.5, which is 19.25. Now, you can't sit there and guess and check. Takes too long, and you probably won't even get the right answer because it'll be a decimal. The way we do it is we let the width, let x and y be the length and the width of the pen. So, it says explain why 2x plus 2y is 18. What's this 2x plus 2y? Isn't it x plus y is 18? Why is that the case? I just showed you up there with numbers. Because, why? It's the perimeter of the pen. How do you do the perimeter of the pen? Isn't it x plus y plus x plus y? Do you see that? Girls, if I call this x and y, what's the perimeter? X plus y plus x plus y, which is 2x plus 2y, and we were told that he uses 18 metres of fencing, which is the perimeter. So therefore 2x plus 2y is 18. Now, does that make sense? Because we were just doing it with numbers. I was saying 7 plus 2 plus 7 plus 2. 5 plus 4 plus 5 plus 4, etc. X plus y plus x plus y, right? Now it says, hence show that y equals 9 minus x. They've made y the subject of the formula. So, I've got 2x plus 2y is 18. I'm going to take the 2x to the other side. 2y equals 18 plus or minus 2x? Minus 2x. Now, I can divide each term, divide through, or both sides by 2. So I'm going to divide both sides by 2. You're allowed to do that. So y equals 18 minus 2x, be careful, divided by 2. But because you know, this is 2 times y or y times 2. The opposite operation of timesing by 2 is dividing by 2, but you've got to be careful here. Each of these is over 2. So you've got to separate them. It's 18 over 2 minus 2x over 2. Do you get that? All right. So that is why it's 9 minus 18 over 2 is 9. See, each of these is over 2, so you can separate your fraction. Well, that's like me doing something like this. Watch. What's a third? No. What's 1/7 plus 3/7? Isn't it 4/7?
Yes.
You know why? Because you do 1 plus 3 over 7. That's why. Yes. Because that whole thing is divided by 2, yes, you divide each of them. What you can actually do is just divide everything by 2. That's the quickest way. Divide that by 2, divide that by 2, divide that by 2. It's the same as dividing both sides by 2. So divide each term or divide both sides by 2. But what you've got to realize is that you're dividing everything by 2. This by 2, that by 2, that by 2. All right? Instead of having x and y, this will be x, but we want to write y in terms of x as well. See how we've come up with a formula for y? Y is 9 minus x, and we've written y in terms of x as well. Now, part C asks for the area. Now, isn't the area equal to x times y? So the area is x times y, but we've come up with an expression for y in terms of x. So it's x times bracket 9 minus x. Do you know why I'm putting a bracket? Because I'm multiplying the x by 9 minus x, which is more than one thing. So this is x bracket 9 minus x, and now I can expand. We okay with this?
Where this got what?
Well, it's x times y, and I've just worked out in part B that y is 9 minus x. So it's x times 9 minus x. Because the x is being multiplied by more than one thing, the more than one thing goes into brackets, and now I expand my bracket. X times 9 is 9x, and x times negative x is negative x squared. So that is my formula for area. Area is 9x minus x squared. Now, the question is to find the largest possible area for the pen. So we're going to have to find the value of x that gives y the largest value. So I'm going to start with a table of values because I have to sketch it. Well, I'll see if I need to sketch or not. So girls, this is normally y and x, isn't it? So it'll be x and a. What do you start off with? What would be some values? X can never be negative. X is a length. X is a side length, and so is y. So you can start with 0, but it'll never be 0. You can't have a length of 0, but I'll put 0 in anyway. So if x is 0, what's a? Anyone? 0. Now, what is the very biggest that x could be? 18. Because you've got, no, not 18. We're going to go up to 9. Because you could have 9 and 0, but that would give you no area as well, because then you've got to go 9 and 0. Remember, we've got 18 meters of fencing. So 9 and 0, 9 and 0, you can't have 0 length. That will never, and you can't have x as 0, but I'm putting them in, but they would be the absolute maximum and minimum. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when x is 9, 9 times 9 is 81, minus 9 times 9 is 81. We already know that if x is 9, you would have no area. Didn't we say if x was 9, that would have to be 0 because the perimeter is 18? Yeah. So if x is 0, you get no area. If x is 9, you get no area. All right? So now we're going to try the other values. When x is 1, you should be able to do this one in your head. 9 times 1 is 9, minus 1 is 8. When x is 2, 9 times 2 is 18, minus, what's 2 squared? So 18 minus 4 is 14. When x is 3, 9 times 3 is 27, minus 9, 18. We're getting there. When x is 4, 36 minus 14 is, minus 16 is 20. When x is 5, I get 20 again. Right. This is the type of example I wanted to show you. When x is 6, 54 minus 36. See how we've reached the bottom, but we haven't found the minimum. Remember a parabola? You know, what is this shape? Don't worry about this 9x, but this minus x squared is a concave down parabola. Parabolas do not go like this, like that, and come back down. They keep curving. So the minimum is going to be between 4 and 5. Do you see that? I've got the two same values for 20. This is the problem. 20 is not my minimum value. There is only ever one vertex of a parabola, one minimum, and it lies between those two. Okay, if you put in 7, you should get 14. If you put 8 in, you'll get 8. And if you put 9 in, you get 0. Can you see the symmetry of the parabola? So, if I sketched this very quickly, it would look like, I'm just going to do a quick sketch. It looked like this. 0, 9, And at 4 and at 5, I've got 20, right? At 4 and 5, I've got 20 as my area. So this is my area versus x. 20 is not the maximum area. It lies between the value of 4 and 5 for x. Do you get that? Where you see two same values in the table. That is not the maximum. So the maximum area is when x equals 4.5. Are we okay with this? You can't have two same values. There is one single value in between. It's probably only about 21 or 22 as well. All right, so let's substitute that into the equation. Area is 9 times 4.5 minus 4.5 squared. Anyone got me an answer? Sorry? 20 and a quarter? 20.25 is the maximum area. Okay? Because whenever you've got a parabola, yes, it's symmetrical, there has to be a value in between. So this here is 4.5 comma 20 and a quarter, 20.25. We know it when we see the table. We're expecting one single value in the middle and we don't have it. So it will be, because it's symmetrical, exactly halfway between 4 and 5. Okay, so that's your maximum area. And the last question is, what are the dimensions of the pen that give the maximum area? So the dimensions are x and y, but doesn't y equal 9 minus x? So the dimensions are x and 9 minus x. Are we okay? It's always a square, girls. It's always the square. So it's 4.5 and what's 9 minus 4.5? 4.5 as well. Girls, the dimensions are x and y, but we know that y is 9 minus x. Remember we did that in part B? So the dimensions are 4.5 times 4.5. In other words, it's a square. Now you'll find that the dimensions that give the maximum area are the square. Okay? Your problems, you're going to have two types, two possibilities. One of them where you've got all four sides that you have to build. There are other types where there is an existing fence in place. We're listening? So, Madison, in this case, again, it's 18 meters again, but we've got an existing brick wall. So why put a fence along the brick wall? We're only going to fence 3 sides, okay? Now again, we've got 18 meters of fencing. Look, let's look at this first example. You can use 5 meters there, 8 there. This would also be 5. 5 and 5 is 10 plus 8 is 18 meters of fencing. Obviously, we can build a bigger enclosure because we've already got the existing brick wall on one side. This one is 2. That's 2. That's 4 and 14. That's also 18 meters of fencing. Notice as it becomes longer and narrower, the area gets smaller. But as it gets more like a square, the area gets bigger. And this last one, 6.5. This is also 6.5. That's 13 and 5 is also 18. And the area is 6.5 times 5 is 32.5. This area is 14 times 2 is 28. This area is 8 times 5, which is 40. We're going to do the same thing again, but our formula is going to be different because we've got one existing fence. So it says if x and y are the length and the width. So I'm going to draw it again. There's my fence, or my thing. And here is mine. If x and y are the length and the width, you have to explain why x, and it's saying length and width, so you have to put them in that order, length and width. Explain why x plus 2y is 18. So, isn't it the wire fence equals 18 meters, and the wire fence, isn't it going to be, if you draw a diagram, isn't it y plus x plus y, which is, can you see that? If the length is x and the width is y, you'd have, if you want to fence around here, you've got y plus x plus y, which is x plus 2y. So therefore we can say that x plus 2y is 18. Okay, this is a fixed wall. You don't need fencing along the wall. Okay, notice we keep doing the same thing again. Hence, show that they start with this equation. They'll say, explain why this is the case. Then they'll say, show that y is. So we're making y the subject of the equation. So I've got x plus 2y is 18. Let's just take the x over. X equals 18, 2y equals, 18 minus x. And now I need y to be the subject. Don't I divide both sides? Divide both sides by 2. Now so you're just dividing each thing by 2. Are we okay with this? Divide that by 2, you get y. You okay? So I'll put them all over 2. Is that okay if I do that? I'm putting each of them over 2 so you can see it. I'm dividing that by 2, that by 2, that by 2, but I'm showing it. So that's y equals 9 minus x on 2 is a half x, so that's fine. So y equals 9 minus 1/2 x.
Do we have to write it?
No. 9 minus x on 2 is fine. But it is the same because 1 times x is x over 2. Next question is show that the area is this, negative 1/2 x squared plus 9x. We know if we look at our diagram that the area of the enclosure is x times y. Isn't that just x times this 9 minus x on 2? I'd rather write it as x on 2. And then it's 9 times x is 9x. X times minus x on 2 is minus x squared on 2. Okay? So isn't it x, the area you can see is x times y. X times y. But in part B, we've shown that y is 9 minus 1/2 x. Girls, if you can't do one of the steps, you can still continue on from part C or from part B. It doesn't matter because isn't the area just that times that? X times y. So it's x times y. We've shown in part B that y is 9 minus 1/2 x or 9 minus x on 2. So it's just x times that. And so you expand. You know, this is brackets. I don't need that times symbol. Are you okay for me to remove the times symbol? That's x bracket 9 minus x on 2. So expanding, x times 9 is 9x. X times x on 2 is x squared on 2. But we've got a minus. And now, hence, find the maximum area for the enclosure. Got to do a table of values again. All right? So, so part D, I've got X and A. Obviously, 0 is going to give me 0 area. So let's start. It's not going to be 1 and 2. It's going to be close to halfway. But you're going to have to go a lot bigger than 9 this time because you can go, I think, up to 18. And so that's going to be quite big. Can we jump up by 2s, please? Because this is just going to take a long time. We're not doing 4 sides. Let's go 2, 4, 6, 8, 10, 12. It's going to be roughly halfway through. The problem here is it doesn't go up to 9. I'll show you why. Because you could have, look, here's 14 and 2. You could go 16 with 1 on each side. That gives me 18. Do you get it? Or I could have 18 and 0, 0. So, but 18 is going to give me 0. Can someone do that? 9 times 18 minus 18 squared on 2. It should give you 0. But I'd like someone to check it. So, it is 0 because it's basically a flat line with no, it's all length and no width, right? So, look, girls, it is going to be, so when x is 2, I've got 18 minus 2, I think I get 16 here. When x is 4, I get 36 minus 8 is what? 36 minus 8, 28. When x is 6, I get 54 minus 18. 54 minus 46.
You say 54.
Yeah, 54 minus 18,
It's 30.
36. When x is 8, I get 72 minus 32. That's 40. When x is 10, I get 90 minus 50, 40. All right, can you see what's happening?
Yeah, we've done good.
It's probably going to be 9. More than likely. Can you check 12? When x is 12, I get 108 minus 72. And 14 should be 9 times 14 minus 14 squared on 2 should be 28.
Oh, Jesus.
And can someone check 16? Should give me 16. So can I have people checking 14 and 16, please?
14 is 28.
Good. And someone check 16? It should be 16 as well. All right. Can you see where this maximum's going to be? Like my parabola's going up, up, up. This is so, just a quick sketch. This is my parabola. 0 and 18, right? The question might be, why can't you have x is 0? Because you would have no area.
9 is 40.
Do you get that? You'd have no area. You'd have just a width and no length, or a length and no width. So we know that, for example, at 8 and at 10, we're hitting the value of 40, but somewhere between 8 and 10, and it will be halfway because of the symmetry of the parabola, we will have the maximum. So the maximum area is when x is 9. Again, about in the middle. It's in the middle. So area is 9 times 9 minus 9 squared over 2. That's 81 minus 40 and a half. Is that 40 and a half? Notice it's very close. Don't say, I'll just put 40, that's good enough. It's not good enough.
It's 40.
It's 40.5.
Yay.
So the maximum area is 40.5 meters squared when the dimensions are what? They're x and y, x and 9 minus x on 2. You okay with that? It's when x is 9. So it's 9 and... So the dimensions are x and y, right? They're x and y. But y happens to be 9 minus x on 2. So the dimensions will be 9 for the x and 9 minus 9 on 2. Sorry, running out of room. 9 times 4.5 meters. Because you got 9. The reason that works, look, this is your fence. You've got this. Look, you've got 9 here, 4.5 there, 4.5 there, and there's your wall. Does that make sense? Because remember, you've only got 18 meters of fencing. So the dimensions are x and y, but y happens to be 9 minus x on 2. So we know it occurs when x is 9. So you put 9 here and 9 for that y value. 9 minus 9 on 2. So it's 9 times 4.5. So those dimensions are x and y, but y happens to be 9 minus x on 2 from part B. This one's not a square because you're only building 3 sides of the wall. All right? So, but I'll tell you where it is. It's in the middle. If you know the end points, it's in the middle. Do you see that? 0 and 18 are the ends. 9 is in the middle. And the other one, it was in the middle. So, sorry, it's not always a square. Only if you're building 4 sides will it be the square. If you're building 3 sides, it's going to be often, but you need to know the endpoints. Look, you're looking for those 2 middle values. You're looking for the symmetry. Once you've found the symmetry, you know it's halfway between those 2.
Do you have to, at the end, you know, I write the dimensions are?
Yes. Yeah, because it's asking for the dimensions.